And maybe always have a peek at page 48. That's where the keywords are found, or your study sheet if you have them already on there. So we'll write the inequality for the following scenarios. Make sure we define the variables. Not sure if I did that on the key. A fridge displayed can hold up to 900 cubic centimeters. So we will call X number of fridges. Right? Actually, in this case, it would be the capacity of the fridge. That's what you would have to write here. Fridge capacity in cubic centimeters. So the fridge can hold up to 900 cubic centimeters. So the capacity of the fridge has to be less than or equal to 900. Page 44. In order to for the university to offer a Spanish course, it needs at least 12 students registered for it. Okay, so you could go with Y, but I'm going to say let X be number of students registered for Spanish, of course. And by the way, the top here, because only X is present, technically this is the implicit constraint. It's just X. Same here. X would be greater than or equal to 0. I know I probably didn't do that on my key, but it's a good habit to just state the implicit constraint. Implicit is it's assumed, but it's kind of hidden. Explicit is if you would say it explicitly, right? So we're technically turning an implicit restriction into something explicit. So if this is our Spanish course, we need at least 12 students in it. So we would go greater than or equal to 12. So far just one variable at a time. Farmer grows potatoes and sunflowers. In order to profit, she needs to harvest a combined weight of 1,500 pounds. So here we have two variables. There will be potatoes and that would be in pounds. And then you have sunflowers also in pounds in this case. Within this context, it has to be pounds. So the combined weight, so the pounds of potatoes and the pounds of sunflower, needs to harvest a combined. Did you read that within the context it has to be at least? It didn't say it, but in order to profit, has to have this or more, right? You would still profit if you harvested more. So in that case, you would want the combined weight to be 1,500 or more. Okay. Question implies at least. And you know, sometimes you just write your inequality, okay? Write it and then go backwards and ask yourself, what should X and Y be for it to make sense? That's fine for you to do it. A daycare takes care of toddlers and preschoolers. Based on the staffing, the daycare can accept 50 children combined. So within this context, right, we're talking number of children here. There's a restriction on the number of children, so we would say number of toddlers. You can do it, you can go toddlers and a number of afterwards, or you can do it the way I'm doing it here, number of pre-K students. And of course, we'll say that x as well as y has to be greater than or equal to 0. Implicit constraint. And then let's write this. So we would just say x plus y, right? The combination of children has to be less than or equal to 50. Right? It could be up to 50, but no more. So that would be the restriction there. And now we're going to have a bunch of moving parts. So right now I just gave you one statement, but what if I have a bunch of restrictions all happening at the same time? All happening at the same time. So let's do that part here. Spence, a DJ, is often hired to play at birthdays and weddings. Okay? Birthday event usually takes about 3 hours, while a wedding takes 5 hours of his time. That's including setup and cleanup. He earns a flat fee of $450 for a birthday party and $625 for a wedding. I would argue that at this point it's all just information, no restriction yet. I don't know if you've noticed that. There's no restriction there. And I'm going to be pretty good at having bullets when it comes to restrictions, okay, on word problems, because I find that it's already difficult as is. So here we go. Here are the restrictions, which means you're going to have an inequality for every single statement here, for every single restriction. Spence has at most, right, 40 hours per week available. Now, I think I failed to do something, probably the most important thing, is what is X and what is Y. I think while reading, you would all agree that it's birthdays and weddings, okay? What happened there? Birthdays, weddings. And I think you would probably agree that it's the number of birthdays, number of weddings, right? You could maybe argue, well, it's the hours spent at a birthday, the hours spent at a wedding, but I'm going to go with number of. Yeah, those are gonna be my units there, and it's a word problem, so just so Mr. Dirksen doesn't complain, right? Because that's what he likes to do. We'll just go x, y, both have to be greater than or equal to 0. Let's get that out of the way. And now let's come up with a restriction. Sorry, I jumped a little bit there. So we have at most 40 hours per week available. Maybe what I will do here, I don't know what I did on my key, okay? So, but I will say there's a restriction on the hours here. Restriction on the hours. So what you need to do is you need to go up in this case and say that, right, it takes 3 hours for a birthday and 5 hours for a wedding. Right? So if you want to talk about hours, in this case, we're going to use these coefficients for our inequality. So we would go like this. 3x plus 5y. Right? So for a birthday, it takes 3 hours, right? And for a wedding, 5. And that has to be a combination of at most 40. Can I just say something here? If you had, you're busy writing this down, I get it. But if you had omitted, let's see if I can do this. Let's say you had just gone x plus y is less than or equal to 40. Then you're saying that, you know, the combined between birthdays and weddings, you want to do up to 40 events. That's what you're saying there. But we're talking about hours, therefore we use these coefficients like that, And now we're talking hours, okay? So you have to be careful with that. Next, Spence would like to earn at least $2,300 per week. Earn at least $2,300 per week. And that's where you use the $450 and the $625 for a wedding. How about I'll highlight birthday and wedding like that. Right? That statement right there has dollar amounts. So I'm going to go 450 for a birthday, right? That's how much you make for every birthday, and 625 for every wedding. And you want this combination, whatever a combination of events, you want that to be greater than or equal to $2,300. Okay. How about I'll do this one more time. This is hours. This one talks about dollars. Okay. And then next, Spence would like to DJ at most 9 events combined per week. This is just events, right? Number of, basically, number of events. So between birthdays and weddings, right? At most 9, so that has to be less than or equal to 9, right? That's where you just have a 1 and 1 in front of the variables. Next, he would like to DJ a minimum of 2 weddings per week. Notice that it's only talking about weddings. This is our Y variable, right? Only refers to Y. Okay. Doesn't talk anything about birthdays. So you go Y has to be greater than or equal to 2. Right? The number of weddings has to be 2 or more in this case. And I see this statement should have been at the very top. Define your variables and write your inequalities. I'm just going to go arrow. If you did this already, if you did the homework, obviously you're going to have it there. But I think that should have been the first step there. So get creative. Ask yourself, is there a coefficient in front of x and y? Next question is this referring to both or is it just to one of the variables? Is it specific to one or is it not really saying specific to one? Okay. And then the next one would be to determine which way should that inequality be pointing, which way should it be facing, and that's where you have your keywords there. Okay. Is that making a bit more sense? It takes a while, but I think you can do it. You're a smart bunch. Let's go to 45. I'm gonna give some stuff away that will help you wrap your head around this. A food stand sells pulled pork sandwiches and hot dogs. I think you all know that you're gonna get your X and Y out of that. Cost to the owner of the food stand is $1.25 per sandwich and 50 cents per hot dog. So it costs the owner that much. The owner of the stand profits, so that means makes $2.50 per sandwich and $1.50 per hot dog. So both dollar amounts, but one is the cost, one is the profit. So things going on here. Restrictions. How about let's define our variables and do all that first. I'm going to go down here. I need to change that. I don't like that it's down here. Let's go with X and Y. I think you would all say sandwiches and hot dogs. I think I would probably imagine most of you would have that. Now we need to ask, like, what are units in? And I think it's number of. That would make most sense here. And if it doesn't, you come back later and change it. Because I read my inequalities and see if it makes sense. X, Y is greater than or equal to 0. And this would be discrete as well, by the way. And let's write some inequalities here. The owner of the stand has a budget of $750 for all supplies needed to sell both products. If you have a budget, okay, of $750, that means that's how much you have to buy stuff. Okay, and so we would say, well, you can spend $750 and divide it up as you wish to buy enough supply. So we're going to say this. This one deals with the cost. Right? This particular inequality will deal with the cost. So it's $1.25 X, right, for every sandwich, and 50 cents for every hot dog, and that has to stay below 750. Would you agree with that? I didn't have the keywords here. I did not have the keywords. But it has to be, right? If that's your budget, if that's all you have to spend, right? So I will say this, implies up to. Okay? Implies up to. Next, a food stand has enough supplies to serve up to 650 sandwiches and hot dogs combined. There's the keyword up to. That is a giveaway for it. It's a restriction. So we'll say, well, the number of sandwiches, and hot dogs has to be less than or equal to 650, right? You have up to 650 combined in that case. The owner would like to profit, right? Maybe, I didn't highlight earlier, but the budget here referred to the cost, and the profit, right? Profit of at least 1,000, you're going to use those numbers there. So $2.50 for every sandwich, and it's $1.50 for every hot dog. Sorry, don't forget the Y. And this combination has to be greater than or equal to 1,000. The owner of the stand would like to sell at least twice as many sandwiches for every hot dog sold. This one is the trickier one that you haven't done yet. Okay? Twice as many sandwiches for every hot dog. So this is how I would suggest. I always like Y here and X there. Okay. Which one do you want to sell more of? If you read it like this, do you want to sell more hot dogs or more sandwiches? Sandwiches? Sandwiches. So which one of these is your sandwiches? It's this one. So I would say for sure you start like this. You start with more. You want more sound. You want this to be more than that. And now the 2, that's the one that's tricky for students. Okay. You'd like to sell at least twice as many sandwiches for every hot dog. Okay. So you go over here, and these are your hot dogs. Okay. So it's counterintuitive. It's counterintuitive. You're gonna put the 2 in front of the hot dogs, like this, because whatever your hot dog sales are, you want to double that or more. Okay, to compare it to X. So let's say, let me give you an example here. Example. if you sell 10 hot dogs, sorry, it's way on the side here. Example, if you sell 10 hot dogs, right, then you would go, well, 2 times 10 is greater than or equal to x. 2 times 10 is 20, right? That means that the number of sandwiches, you would want it to be greater than or equal to 20 in this case, right? And if you sold 20 hot dogs, then you plug in 20, you would want to sell 2 times 20, you would sell more than 40 in that case of the hot dog. So it's always counterintuitive, right? If you wanted to do it the other way, if you wanted to sell at least 2 hot dogs for every sandwich, then the 2 would actually go in front of the x. It would be the other way around. This one is tricky. You can actually write down tricky, right? But it doesn't happen very often, but it does show up from time to time. One more. I find it very important to go over this, not just assume that you will get it, because it's tricky. I know it's tricky. Okay, Emily has 2 part-time jobs working at Canadian Tire and Wendy's. Yay, right? She earns $11.45 an hour at Canadian Tire, while at Wendy's you get $12.50 an hour. That's just a fact. Emily would like to work at most 30 hours per week. This is an inequality here. Inequality number 1. And this gives it away. Right? There's a restriction. And next, Canadian Tire requires Emily to work a minimum of 9 hours per week. So minimum of 9 hours per week, that is inequality number 2. There's another restriction. Next, Emily would like to earn at least $225 per week. At least $225, that's another inequality. Inequality number 3, which technically is a restriction. I'm going to give you a bit of time to try this. If you already did this, if you know what the answer is, then just sit back and relax. But I want you to write out those nonsense is all about. All right. Inequality 1. At most 30 hours. Okay, minimum of 9 hours. There seems to be hours and dollars here. But let's define our variable first. X, Y. I think you would all probably go Canadian Tire and Wendy's. What would the units be? Number of Canadian Tire? Doesn't make sense. Number of hours? Probably, right? And this kind of gives it away that you're getting dollars per hour, and there's hours there, so hours, okay? I know it might be insignificant to some of you, but it does matter. So, and both of them have to be greater than 0. And by the way, this is an example of continuous. Okay, most data is discrete, but sometimes you have continuous, and this is one of the cases here. Okay, at most 30 hours per week. It doesn't isolate just one or the other. It doesn't say just Canadian Tire, just Wendy's. So it's both combined. So the number of hours combined at most 30. Okay, can't work more than that. Then it says Canadian Tire, specifically Canadian Tire. requires Emily to work a minimum of 9 hours. So we go just with Canadian Tire, and that has to be a minimum of. So whatever X is has to be greater than or equal to 9. And now it's earning time. Okay, we'd like to earn at least $225 an hour. 225 per week. Sorry. So that's where you use the coefficients. 1145 working at Canadian Tire plus 1250 Wendy's. That has to be at least $225 in this case. And there you have it. I could have had another statement here that speaks specifically to Wendy's, for example. Wendy's will not let you work more than 20, let's say. Then that would have been a horizontal line, right? There would have been Y and so forth. So I could have added more to this if I had wanted to. And by the way, the next step is going to be graphing this. That's going to be our next go-to, all right? But first I need you to write, because if you don't know how to write, you'll be graphing the wrong inequalities and you'll be so frustrated, right? So I first want you to write and then we'll graph. So now let's do the AC. So because the true region is below, we must shade below if it's regular. Okay, so I would give you basically 1 mark for rewriting and then half a mark for telling me where to shade. So if you didn't flip, you only get half a mark, right? Provided then you would say it's above. And then when you plug in -1, -15 into this the original here, right? -2 times -15 is +30, and on the other side you got 25, right? Because 5 times -1 is -5 plus 30 is 25. So I don't know why I put false at first, but you can tell I changed it. So it's true. So therefore it is a solution. Is a solution, right? So make sure you finish that sentence there. And then here are your, and I do see some slopes all around for the most part. Yeah, 2, 7, I see a lot. So this one should definitely be negative because it's dropping from left to right. There's a 2 drop and a 7 run. So that's your slope. So I give you 1 mark for the inequality, for the symbol, and 1 mark for the actual equation part of it, right? The slope and the intercept. And it's regular shading, so the shaded part is the true region. So for line A, that is a vertical, it's dashed. So since the true region is to the right, I go greater than, goes through 3 here. And the Y line goes through -2, and it's solid. True is below, so it'll be less than or equal to -2. So that's 1 and 1 for those two questions there. So 1 and 1, and 2 for this one here, because it's a little bit more work. So that's where the 4 come in. So this whole thing is out of 12. So at the top, put your name and last name and a mark out of 12. You're the teacher. Sometimes I disagree with you, but we're usually not off by a whole lot. Okay, I gave you back a bunch of ACs. You can use those as well.